Wallace micro Hardness tester is being switched on. It will check the indent of system, go down, check the reference table, go up to its home position, and further the machine gets signal from all the circuits, controls, and it's ready for operation after the beep. Now we put all specimen from 1 to 4 mm thickness. According to the sample thickness, we can adjust the footer up and down by pressing up or down switch. Normally we keep around 3 to 4 mm clearance between the sample top surface and the footer, and then we just press the button and press the start button in the machine. When we press the start button, the footer just goes up and then comes down, locate the sample, apply the correct footer force, and then the footer LED will become green color. Once that is sensed, force 1 is applied. Force 1 as per ASTM standard is applied in the machine. Then force 2 is applied. Then the hardness reading starts showing. And so force 2 is applied for 30 seconds. At the end of 30 seconds, the hardness reading will freeze, and that will be the value of the rubber hardness in IRSD scale. Now the test is over, indenter goes up and the value is displayed in the instrument, and further this value can be transferred to the computer in Excel program if we have the software version of the machine. This is O-ring table used to check the hardness of rubber O-rings in the micro Hardness tester. If you notice, there are 2 pins located here, and the minimum distance between the 2 pins is 1 millimeter in cross-sectional diameter, and this can go up to 5 millimeter by rotating this knob. If you notice this, when I rotate this knob, the 2 pins are going outwards and also it is coming upwards. So you can, the maximum distance from one pin to the other pin, even though they have given a provision of up to 8 millimeters. Normally micro Hardness tester is used up to 5 millimeter CSD in O-rings. Similarly, when we check small O-rings, we can rotate this knob and bring the pins closer so that the O-ring can be located correctly. Now we will see how we check the O-ring in the instrument. First of all, we will take the footer upward position so that there is sufficient gap. Then we can simply remove the flat table. Flat table can be removed, and then if you notice, there are two locating pins available here. These 2 locating pins can be put into this pins. Just slide it easily like this and then lock it. It gets locked. Once the table is locked, it's ready for operation, and then we can test the O-ring. Normally what we do is we put the O-ring in between the pins so that it seats in between, and then we hold the O-ring down and then tighten this knob. Once we do that, the O-ring is already located, and the cross-sectional area, the top portion of the cross-sectional area is exactly aligned with the indenter. So this way, any O-rings from very small diameter to large diameter can be tested very fastly using this table. Now we will see how we test the hardness. Once the O-ring is located in between the pins, as normal operation, we press the start button so that the footer will at first comes down, locate the O-ring, and then the footer LED will change into green color. After that, once the footer is flat, force 1 is applied by, you can see the red LED, and once it becomes green, then second force is applied, that's secondary force. Then when the secondary force is applied, you can see the hardness is changing and the indenter is penetrating on the rubber. And this process will continue for 30 seconds, and at the end of 30 seconds the display reading will freeze, and that will be the hardness of the O-ring. Now the test is over. This is the hardness, and this data also can be transferred into the Excel program of the computer if you buy the optional software and the PC version instrument. So this is how very easy the instrument is easy to operate for even small flat rubber pieces, as well as any O-rings from 1 to 5 millimeter can be tested easily.